Good morning, everyone. You're welcome to Maths Guru, and I'm Daniel. I'm going to be taking you guys on chemistry today. But before we talk about chemistry, I just want to talk about some of the things students think about chemistry. Many students think that chemistry is complex, chemistry is difficult, chemistry is what have you. But I'm here to let you know that chemistry is difficult, it's complex. Yes, I agree with you on that. But chemistry can be understood. Chemistry can be simplified. It depends on what you are reading and what and the person teaching you. Because a lot of students read, but I have a question for that student that said, "Oh, but I read a lot, yet I don't understand chemistry." What do you read? Because what you read determines the information you are going to get. Chemistry, if you must know, I just want to tell you two things about chemistry. Why chemistry seems to be very complex and very difficult and all that. One thing you need to know about chemistry is that the fathers of chemistry thought that chemical reactions takes place due to some spiritual forces. They see it like a magic. They were called the alchemists. And they even have this belief that when substance born, now in chemistry we say when substance is born, it is because of the presence of oxygen. But the alchemist believes that when substance is born, they do so because they have a particle called phlogiston. That's what they call the phlogistomic theory. We are not going to dwell more on that. But as time goes on, a law student, which is known as the father of chemistry today, Lawrence Lavoisier, he was a law student then. He went out to make research. He said he won't accept that phlogistomic theory. And you see, chemistry, that's one of the problems of chemistry. The people that started it. And number two, one of the problems of chemistry is that the topics are related. Like not like physics. The chapter one has nothing to do with chapter two, and so on and so forth. But chemistry, chapter one has everything to do with chapter two. When you don't understand matter, you cannot understand chemical composition and all that. So now, I must commend. You must be very lucky to be in this group. You're very lucky to see this video because we are going to be dealing with most of the problems in chemistry. But what we are going to do now, we are going to start from the calculations in chemistry because I discovered that the calculations in chemistry have a lot to do with the students. So we are going to talk about the calculations in chemistry, and today we are going to start with Boyle's law. And I'm going to give you a lot of bombs, a lot of shortcuts which you are going to use to solve any question on gas laws, electrolysis, stoichiometry, and what have you. But today we are going to be looking at gas laws. Stay tuned and don't forget to subscribe to our channel and also hit the notification button to get notified whenever we upload a new video, and also hit the like button. Preview. Start. Okay, so now we are going to be talking about gas laws as we initially said. So now in gas laws, you need to understand that it's divided into two parts. We have the theoretical part and we have the analytical part. Go. So we have the theoretical part and we have the analytical part. The theoretical part is just talking about the behavior of these gases, and the analytical part is talking about the what constitutes this behavior at this pressure and at this temperature, what is happening to the gas, calculating these things. That's just the theoretical part, sorry, the analytical part. Now we need to understand that gas laws, when you're talking about gas laws, you are talking about four variables. And what are these four variables? We're talking about the pressure, we're talking about the volume, we're talking about temperature, and we're talking about number of moles. And we know our pressure is either at atmosphere. Our standard pressure is 1 atmosphere, or you say 760 millimeter of mercury, or you say our pressure is or our pressure can be 10135 Newton per meter square. Per meter square. Then our volume can either be 22.4 dm cube or 22,400 cm cube. Now temperature can either be in degrees Celsius or Kelvin. Now we need to understand that the theoretical part plays a vital role in the analytical part, because the theoretical part is, let's talk about the theoretical part. The theoretical part is telling us that gases possesses average kinetic energy. Now this theoretical part is what is known as kinetic theory. Kinetic theory of gases. And what's a kinetic theory of gases? Number one, it says that molecules of gases acquire kinetic energy when heated. So when there is a temperature, when a gas is heated, when the temperature of a gas increases, that gas acquires kinetic energy. Now it also says, the number two says that the gases which acquires kinetic energy are in random motion. They bombard each other and the walls of their container, and their collision is elastic. Now this is just the theoretical part, talking about what happens when this happens and what happens when that happens. Now going to the analytical part, that is what I want you guys to pay attention to, the analytical part. Now different scientists came together, made research, personally, privately, made their research, and they discovered so many things. They discovered that there's a relationship between pressure, volume, number of moles, and temperature. Now what are these laws? Now this experiment carried out was later made laws, and these laws are what we call the gas laws. And what are these laws? Number one, the Boyle's law. Now what does the Boyle's law say? The Boyle's law says that the volume of a fixed mass of gas is inversely proportional to the pressure. Removing this constant of proportion, this sign of proportionality, we have our V to be equal to K over P. Therefore our K is equal to what? Vp. So we can say V1 P1 is equal to V2 P2. This is the Boyle's law. So when there's an increase in volume, there will be a decrease in pressure. That's why you see, when you are in biology, when there's something that happens when you like block your nostril and you force air out. the pressure will increase in your ear, blocking your ear, so you'll be unable to hear very well. But when you take in air, like you are salivating, that pressure will decrease. Why? Because there's an intake, there's an increase in the volume inside. And also when we breathe, when you breathe, when your lung contracts, there's an increase in pressure, so it will now pump air out. And when it relaxes, it will bring your air in. So that's voice law. We can also use a good example is the football. When you apply pressure to a football, you see that the volume will escape, because an increase in pressure will cause a decrease in volume. But when you reduce the pressure, the volume will increase. That's Boyle's law. Now the second law is the Charles law. Charles law states that the volume of a fixed mass of gas is directly proportional to its temperature, which means that our volume is equal to kT, and our K is equal to what? V over T. So we can say V1 T1 is equal to V2 over T2. So when there's an increase in volume, there will definitely be an increase in temperature, or when there's an increase in temperature, there will definitely be an increase in volume. We are talking about gas laws. Because how do we explain this? We'll talk about this. I will explain more of this when we get to the ID gas equation. That's where I will explain something about this. Why does the volume increases in gases when the temperature increases? Now, Amendo's law. Now, this law is by Amendo Avogadro, which says that equal volume of gases contains the same number of molecules. Equal volume of gases simply means that the volume of a fixed mass of gas is directly proportional to the number of moles, which means that V is equal to Kn, making K to be equal to what? V over what? N. So V1N1 is equal to V2 over N2. Now, I just want to let you know something before we go into the last law called the pressure law. I just want to let us know something. Any gas that obeys these three laws is called an ideal gas, because remember, the ideal gas equation was gotten from these three laws. So for a gas to be called an ideal gas, that gas must be obeying these three laws. Now let me prove to you what I'm talking about. From here we can see that volume is directly proportional, is inversely proportional to pressure, directly proportional to temperature, and directly proportional to what? To number of moles. So what does that mean? Volume is what? Is directly proportional to temperature, directly proportional to number of moles, but is inversely proportional to pressure. This is the relationship between volume, temperature, number of moles, and pressure. Now, removing the sign of proportionality, volume is equal to R Tn over P. This is a constant of proportionality known as the universal gas constant. Rearranging, we can say that PV is equal to nRT. This is what we call the ideal gas equation. You can see that the ideal gas equation came out from these three laws. So for a gas to be an ideal gas, that gas must obey these three laws. For a gas to be an ideal gas, you must obey these three laws. Now, what is this R has a value? What is the value of R? Now, the value of R is said to be 0.082 atmosphere dm cube per mole per Kelvin. How do they get this? How did they get this value and all these units? It's from this. Now making R, so the formula R is equal to PV over NT, isn't it? Since R is equal to PV over NT, we can see where P, remember we talked about initially we talked about our standard standard pressure. Now so our standard pressure, 1 atmosphere multiplied by V 22.4 dm³ divided by number of mole, 1 mole, multiplied by 273 Kelvin. If you do your maths, it's going to give us 0.082 atmosphere approximately dm³ mole per Kelvin. Remember, if there are some examiners that want to give you a question, and that question they want to give you, they might tell you that 760 millimeter of mercury, 2000 cm³, 1 mole, and 30 degrees Celsius. Calculate the universal gas constant. Although they won't give you a question like that to calculate for the universal gas constant because it's a constant. But I'm just giving you as an example. For example, they might say, they can tell you to calculate the temperature when pressure is equal to 760 millimeter mercury and volume is equal to 200 cm³ and 1 mole. Some people will just rush and apply our pressure is this, volume is no. If you do this, you're going to get it wrong. You need to convert all this to temperature, to the standard temperature and pressure given, and also the standard volume. And how can we convert this? 760 millimeter mercury is the same thing as 1 atmosphere. (200 cm³), we are just going to divide it by 1000 cm³. Whatever you have, you've already converted it to dm³. That will be your volume. Same goes to temperature. If you are given a temperature of 10 degrees Celsius, you just add 273 Kelvin to 10. It's going to, whatever you have, that is the Kelvin. It's going to give you 283 Kelvin. That's the temperature you use. Remember to follow standard temperature and pressure. As we go on, we see questions. But let's deal with the problem before we go for questions. Now, this is the ideal gas. Now, any gas that we said that any gas that obeys these 3 laws is called an ideal gas. And it simply means that for that gas to be an ideal gas, it must be, number one, for a gas to be an ideal gas, number one, if you are being asked what are the criteria for a gas to be called an ideal gas, number one, it must obey these 3 laws: Boyle's law, Charles' law, and Avogadro's law. Number two, that compressibility factor of the gas must be equal to 1.0. If the compressibility factor is not equal to 1.0, therefore that gas is not an ideal gas but a real gas. And it's not, this one is it's an ideal gas. And number three, what is that third thing that will make you say a gas is an ideal gas? When a gas is an ideal gas, the gas will be operating on low pressure and high temperature. But when a gas is operating at high pressure and low temperature, it simply means that that gas is a real gas. What do I mean? Let's go back to the theoretical aspect of our gas law we're talking about. Remember that when a gas is under an high temperature, the gas possesses what? Kinetic energy, which makes the gas to move vigorously. So when the gas is under high pressure, it's going to move and is going to obey these three laws. But when the gas is under low pressure, that gas will be liquefied. The gas will be liquefied. Example of this type of gas is that thing inside your gas cylinder in the house. That thing is a liquid and not a gas, because it's operating under high pressure and a low temperature. Now, if you have any question on this, you can put it on the comment section below. Now, I talked about the last law we are going to talk about, and that last law is the pressure law. Before we talk about the pressure law, let's confirm these laws if they are correct. From the ideal gas equation, which says R is equal to PV over NT, since N is equal to 1, number of moles is equal to 1, what are we going to do? So we can say that R is equal to PV over T. Therefore, we can say that P1 V1 over T1 is equal to P2 V2 over what? T2. This is what is known as what? Our general gas law. Now, let's confirm if these gases are correct. Boyle's law, pay attention to this. Pay attention to this. Boyle's law states that the volume V1 P1 is equal to V2 P2 provided temperature is constant. Now, let's come down to our general gas law. When temperature is constant, what do we have? P1 V1 is equal to what? P2 V2. It simply means that our Boyle's law is what? Is correct. Our Boyle's law is what? Is correct. Now let's go again to our general gas law. P1 V1 over T1 is equal to P2 V2 over T2. Charles' law states that when at standard pressure, the volume V1 over T1 is equal to V2 over T2. Now let's come to our general gas law. When the pressure is constant, V1 over T1 is equal to V2 over T2. Simply means our Charles' law is what? Is correct. Now, what if volume remains constant? When volume remains constant, it means that P1 over T1 is equal to P2 over T2. What does that mean? This is what is known as our pressure law. P1 over T1 is equal to P2 over T2. This is what is known as our pressure law. Now, let's introduce our number of mole. P1 V1 over N1 T1 is equal to P2 V2 over N2 T2. When pressure and temperature is constant, they can cancel each other. What are we having? V1 over N1 is equal to V2 over N2, which means our Avogadro's law is correct. Now, what am I trying to say? Whenever you are given a question on gas laws, what you will do is to write down this formula. R is equal to P1. Take this bomb now. R is equal to P1 V1 over N1 T1. Are you getting me now? Now, when in the question, if R is not given, take it off. If P is not given, take it off. If V is not given, cancel it. If N is not given, cancel it. If T is not given, cancel it. Now, after all the cancelling, the parameters you have left, that is what you will use to solve. We are going to stop here for today, and our next video we are going to be talking about Dalton's law of partial pressure, Avogadro's law, Gay-Lussac's law of combining volumes. So I want to give you just a question to solve and study this, eat it. Then we will come back on our next video. We are going to be talking about other things, but solve these questions and put your answer in the comment section below. And when you have any problem, any question you need to ask, put it down in the comment section below, and don't forget to hit that subscribe button and also like and share our video. Thank you. So here are some questions. You just have 3 questions here for us to solve. Now this first question says, at constant temperature, the volume of a fixed mass of gas is 12 cm cube. With 710 millimeter mercury pressure, what will be the volume? What will the volume be at 760 millimeter of pressure? Remember, get this your equation which says that R is equal to P1 V1 over N1 T1, and see which of these parameters is here and take it out. Remember, you only convert to atmosphere and dm cube when you are solving for ID gas, when you are using the ID gas equation. So let me just give you guys a hint: don't convert this thing to dm cube. Okay guys, thanks for watching. I hope you learned a lot and you um, found out so many secrets about your chemistry gas laws, and I hope you will be around when we do the next video concluding gas laws. We'll be talking about um, 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 Dalton's law of partial pressure, Gay-Lussac's law of combining volume, and I bet you are going to learn a lot. You're going to discover so many things you never knew they existed. So do well to do the assignment, and if you have any problem, don't forget to put it in the comment section below. And if you want to have more than what we are going to do here, have more than, because right here we don't have enough time to do all of that. So if know you want more of what we are going to do here, like the foundations of chemistry, foundations of biology, and the foundations of physics, foundations of mathematics and English language, as far as science is concerned, just contact us on the WhatsApp number that will be on your screen, and we are ready to serve you, and I bet you won't regret coming in contact with us. See you when next we see, and don't forget to subscribe to our YouTube channel and like, and also share with your friends, your family members and your colleagues, and also put a comment on this comment section below about anything you would want us to do. Thank you.